Okay, so in our final topic in solutions, we're going to talk a little bit about two terms associated with solutions. The first one is what is known as molarity, which essentially refers to, sorry about that. First one is molarity, which essentially refers to solution concentration. And then the second one we'll talk about, second term that we'll talk about is what is known as dilution. Well, let's start with molarity first. So in terms of a definition, molarity is defined as the moles of solute per liter of solution. So where did we sort of see moles and liters before? Well, for moles, we saw moles when we talked about molar mass. And we know that for the molar mass is equal to the number of grams divided by the number of moles. So that's where we've seen moles previously. And then liters, where have we talked about liters previously? We talked about liters previously when we talked about volume. And one of the units that volume is commonly expressed in is in liters. So molarity relates these two aspects, moles of solute per liter of solution. And as you could see in bold here, in terms of a mathematical equation, molarity is equal to the moles of solute over the liters of solution. Now, in terms of, and we'll get to this in a moment, in terms of units. So essentially, based on the formula that's here, molarity would generally have units of moles per liter. And actually, we can abbreviate that or combine that in what is known as capital M, which sometimes is pronounced as molar. But when you see that unit next to a number, when you see capital M next to a number, essentially what that capital M means, essentially is what is referred to as molar. Okay. And if you want to break that down even further to what that represents, what it truly represents is moles per liter. But instead of writing moles per liter, a lot of times we just write capital M for molar. Okay. So we're not going to ask you to do any calculations with determining molarity. But what I think is important is to understand the significance of the numbers. And in reality, it's very important in the world of acid and base chemistry. Consider two hydrochloric acid solutions, one that has a concentration of 0.1 molar and the other that has a concentration of 12 molar. If you get the 0.1 molar hydrochloric acid on your skin, it'll tingle a little bit. You wash it off and you probably feel fine and you continue on with the lab. On the other hand, if you spill the 12 molar hydrochloric acid on your skin, we are probably sending you to the hospital because you have to get treated for second or third degree burns. The higher concentration, the higher the molarity of the hydrochloric acid solution, the more potent, the more dangerous it is. And that's sort of generally true for acids and bases. The higher the molarity, the higher the concentration, the more potent, the more dangerous that it is. Okay. And then on the right here in the picture, they just give you a diagram of how they make an actual 1 molar sodium chloride solution. They measure out 1 mole of solid sodium chloride, which I believe is about 59 grams of it. They put it in a volumetric flask and they dilute it with water to the 1 liter mark so that you have 1 mole in 1 liter. 1 mole divided by 1 liter gives you 1 molar or 1 mole per liter. So this is a common methodology that would be used to make to make different types of molarity solutions in what are known as volumetric flasks. Okay. The other term we want to talk a little bit about is dilution. So in a dilution, a solvent, usually water, is added to a solution. which increases its volume and decreases the concentration of the solution. Okay. So how does that work? When you want to essentially, so what dilution basically does is that it takes a higher molar solution and makes it into a lower molar solution. And the interesting part about that is, how is that done? Very simply, it's done by usually just adding water. How does that work? So when water is added to a solution, what happens? The volume of the solution increases. Because if you're adding water, the overall volume of the solution is going to increase, because essentially the volume of the solvent increases, and therefore the volume of the solution increases. But the mass of the solute in the solution remains the same, which means the moles of solute remain the same. Because if the mass of the solute is going to stay the same, then the number of moles of solute is going to remain the same. So adding water does not change the amount of solute that's present. It changes essentially the amount of solvent, which changes the volume of the solution, but it doesn't change the amount of solute that's present. So the mass of the solute stays the same and the moles of the solute stay the same. So if you go back to the molarity equation on the bottom, if the moles of solute stay the same, which is our numerator, and the liter or the volume of the solution increases, which is our denominator, what happens to the overall value? Well, if you have a fraction where the numerator stays the same, but the denominator gets larger, the overall number gets smaller. So the end result is that the molarity, or the concentration, decreases. So if you add water, the number of moles of solute stay the same. The volume of the solution increases, and therefore what happens to the overall value? The overall value, which is the molarity, gets smaller. So that's why when you add water, you take a higher molar solution and you convert it into a lower molar solution. And that process is what is known as dilution. And dilutions are done just by adding water. Usually you don't go from a lower molar to a higher molar solution. That's usually not what's done. Usually what's only done is going from a higher molar solution to a lower molar solution.